Assalamualaikum and hi, my name is Natasya Binti Hisham with metric number DN180027 and my supervisor TS Muhammad Fahmi bin Abdul Rahman and IRTS Dr. Muhammad Kamur Zaman bin Musa as my co-supervisor. Today, I'm going to present my project Sarjana Muda 2 entitled Study on the Properties of Bamboo Fibre Containing Concrete Due to Strength. I begin my presentation with abstract. Despite its extensive use in building, concrete offers a number of significant risks, including weak strength qualities, impact resistance, and cracking. This study was conducted to investigate the workability of concrete in order to increase its strength rate. Apart from that, the objective of this study is to ascertain the mechanical and physical properties of bamboo fibre when mixed with Portland cement. Bamboo fibre at 1%, 2% and 3% were utilized as an additive in 0.75 and 1.5 concrete mix. The workability of the mix was assessed by slump. The cement was subjected to a conventional consistency test. Compressive strength was determined at 7, 14 and 28 days for hardened cure concrete cubes. The water absorption test measures how much water concrete samples absorb while immersed. Thermal conductivity testing determines the degree of heat transmission in concrete by conduction, which can cause cracking. For introduction, durability is a requirement for concrete buildings. In essence, the consequence of substandard environmental conditions cause crack in concrete structure, reducing their durability. Despite its widespread usage in construction, concrete poses significant risks, including weak strength properties, impact resistance, and cracking. It is usually considered that as concrete strength increases, its ductility decreases, and so the discovered inverse connection between strength and ductility is properly considered in a few structural applications. A study conducted to overcome the problem of workability of concrete to increase the rate of strength. Concrete is manufactured in a variety of ways, including batching, mixing, consolidating, finishing, and curing. Concrete is one of the most often utilized materials. It is made of three primary components: filler, sand, and cement, which act as a bonding agent and makes concrete. Compressive strength is high, while tensile strength is poor. They are reinforced with fibre to compensate for their low tensile strength. Due to the great energy absorption rate of concrete fibre during collision, it is not readily broken apart. Adding fibre to concrete to enhance its qualities began in the early 1960s. Over the last 6 decades, significant advancements have been made in the addition of fibre to concrete to achieve different desirable proportions. The species of bamboo used in this study is Sumatran bamboo, which can be identified from other species by the diameter of its culms. Generally, Sumatran bamboo has a wide diameter of culms. It is found up to about 1,200 meters in elevation and often spread into disturbed habitats, from lowland to hills area, along streams and rivers, and in valleys. Based on past study, parallel to the grain, Sumatran bamboo has a high compressive strength, elasticity and stress elastic modulus at the proportional limit with respect to the skin at the internal section. The bamboo has been utilized for the construction of structural elements such as supports, column, roof, and others. Next, we move to literature review. From the poster, we can see table some species of wild bamboo. Bamboo is a member of the Gramineae family, which also include wheat, rice, corn, sugarcane, and wheat. More specifically, bamboo is classified as a member of the subfamily Bambusoideae. In Peninsular Malaysia, only around 13 of the 45 bamboo species listed by Holtham are widely used. In this study, we use bulu semantan as bamboo fibre in containing concrete. This is because this type of bamboo is easy to find because bulu semantan is widely logged in Malaysia, especially in Kedah, Perak, Kelantan, Selangor, and Pahang. Semantan bamboo is also easily recognized by its relatively unique physical characteristic. Okay, next, the classified grade of concrete. For this study, we use concrete grade M30 with ratio 1, 0.75 and 1.5 concrete mix. Okay, next is the methodology. For the methodology part, the flow chart is provided to give a clear view of the journey of this study. Firstly, start with identify the problem, then fix the objective. Next is testing followed by physical and mechanical properties testing. For this study, we have 4 testing to achieve the objective. The testing is slump test, water absorption, compression test, and lastly thermal conductivity testing. After settled with all the testing, data collection will begin and followed by data analysis and discussion. And lastly, the last part is conclusion and suggestion. Okay, next is result and discussion. Firstly, for the slump test. From the graph, we can see that the workability of normal concrete is medium, that the slump value is 68.58 mm and that the actual slump is a form of slump. The slump value of the bamboo fiber concrete mixture is 24.5 mm for 0.1% as an addition in concrete, 23.8 mm for 0.2% and 25.4 mm for 0.3%. This value increases as the percentage of bamboo fiber increases. Next is the thermal conductivity when the density is 2316.78 kg meter cube. The thermal conductivity is 0.168 degree for control sample, which is zero additive of bamboo fiber. Then for 0.1% of bamboo fiber, when the density is 1867.61 kg meter cube, the thermal conductivity is 0.210 degree. For 0.2% of additive bamboo fiber in concrete, the density is 2009.46 kg meter cube. The thermal conductivity is 0.177 degree. Lastly, for 0.3%, the density is 2458.63 kg meter cube. The thermal conductivity is 0.224 degree. The amount of air that is contained in concrete mix has an effect on its thermal conductivity. Next is water absorption. The result of the water absorption test conducted on bamboo fiber concrete revealed that the line pressure increased as the proportion of bamboo fiber added to the mixture increased. The rate at which bamboo fiber concrete absorbed water climbed steadily between 0.1%, 0.2% and 0.3%. This increase in absorption rate is attributed to the porous surface and water-absorbing properties of bamboo fiber, which contribute to bamboo's overall composition. And lastly is compressive strength. The graph demonstrates that the sample consisting of 0% has a value that is superior to that the other sample. The present ratio of bamboo fiber results in a reduction in compressive strength, but the ideal ratio of bamboo fiber to concrete is 0% and produce a better level of compressive strength as a direct consequence. On the other hand, the compressive strength of concrete can be made weaker by along with a high porosity in the concrete that has been mixed. Aside from that, the reduction in strength is typically caused by a lack of adhesion between the bamboo fiber and the concrete mix. In conclusion, the result of the compressive strength test, thermal conductivity test, water absorption test, and slump test have been successfully analysed and discussed. Only the control sample has demonstrated to have reached the real slump value as evident by the result of the slump test. The workability of the remaining 3 types of mixed materials is very low and they create zero slump as a form of slump. In addition, the most important guideline is that a high slump value implies strong workability, whereas a low slump value suggests low workability. Furthermore, the size of the Air spaces contained within concrete mix has an effect on the material's heat conductivity. The effect of heat transfer caused by convection via the air in the sample will be reduced in proportion to the sample's smaller air space sizes. Aside from that, it is possible to draw the conclusion that the proportion of bamboo fibre present in the concrete mix has an effect on the amount of water that the concrete is able to absorb. In conclusion, compressive strength decreased after bamboo fibre was added to concrete. This decline in compressive strength occurred despite an increase in the percentage of bamboo fibre used as an additive in concrete. Correspondingly, the compressive strength value of the bamboo fibre concrete mixture decreased. That's all from me. Thank you.